Hey everyone, and welcome back to The Explainer. Today, we are exploring a concept that pretty much flips traditional economic theory completely upside down. We're drawing directly from a seriously fascinating paper by Sergio da Silva titled Granularity, Macroeconomics and Beyond. So if you've ever wondered how the gears of our global systems actually turn behind the scenes, well, you are definitely in the right place.
So think about this for a second. Can one single company having a really bad day actually crash the entire economy? I mean, historically, economists would probably just smile, shake their heads, and tell you, no way. They'd argue the system is way too vast, too perfectly balanced for that. But what if they were wrong? What if the hidden architecture of our world actually allows a single monumental domino to just topple the rest of the board? That is exactly the high-stakes mystery we're going to unravel today.
Here's our roadmap. We're going to start with the economic shock mystery, introduce the granularity hypothesis, jump into power laws and granular size, check out real-world market applications, and then we're going to leap way beyond economics into nature and science.
Okay, let's dive right into this. Part 1, the economic shock mystery. Let's set up the classic problem we're dealing with here.
For decades, understanding exactly why small shocks cause massive economic fluctuations has been, frankly, the holy grail of macroeconomics. Traditional explanations are usually really broad. We're talking about huge systemic forces, things like investment and capital cycles, Keynesian multipliers, credit market disruptions, or constrained monetary policy. But here's the wild part. For a really long time, the idea that a minor shock to just one single individual firm could ripple out and disrupt the entire economy, it was completely overlooked. People just didn't take it seriously.
So, moving on to Section 2, enter the granularity hypothesis. Time to fundamentally rethink how these systems are structured.
To really get this, we have to contrast two totally different ways of viewing the world. The old school of thought relied heavily on the law of large numbers. Basically, imagine an economy like a beach made of perfectly identical tiny grains of sand. That's a smooth economy. If one grain gets moved, the beach looks exactly the same, right? The shocks just neutralize and average out. But the granularity hypothesis says, nope, the economy is not fine sand. It's actually chunky. It's a beach that has these massive boulders mixed in. And if a shock hits one of those boulders, the entire landscape changes. The shocks to those few massive firms absolutely do not get neutralized. They disproportionately impact the whole system.
And that brings us to a really vital term, the granular residual. Because the economy has these massive boulders, unique shocks to them don't just magically fade away. The granular residual is the combined impact of those specific firm-level disturbances, scaled up by the firm's sheer massive size. When huge firms take a hit, this residual is what actually drives the overall business cycle. It's not just broad economic weather. Actually, scratch that. It's more like a localized Category 5 hurricane at a single megacorporation that ends up dictating the entire national GDP.
All right, Section 3, power laws and granular size. Let's look at the mathematical backbone of all this. The crucial point to understand here is that without a power law, we wouldn't even have these massive grains in the first place. Normally, we tend to think of things fitting neatly into a bell curve, right? Most things are average, and extreme outliers are super rare. But firm sizes don't work like that at all. They follow a power law, which has what statisticians call a heavy right tail. This means extreme values, these exceptionally huge units, are way more common than a normal bell curve would ever predict. The power law is the mathematical bedrock that allows these mega firms to exist and hold so much power.
Okay, but how do we actually find out how many of these big grains matter? Well, that is where we calculate the granular size. Out of thousands, maybe millions of companies, the granular size tells us the exact number of top-ranked giants that are actually pulling the strings of the entire system.
And this brilliantly illustrates how we find that number. If you take an equal weight curve, where we pretend all firms are magically the exact same size, and you cross it with a granular curve that maps actual reality as we start peeling away the biggest firms, that exact point of intersection, boom, that perfectly calculates our granular size, or K-star. It gives us the precise number of top-ranked firms that dominate before the rest of the market just dissolves into background noise.
Section 4, real-world market applications. Let's zoom out from a single company and see how this impacts global markets.
Because this is where it gets incredibly practical. This is not just some abstract mathematical thought experiment. Firm-level data from around the globe, we're talking the US, Europe, China, Brazil, proves that unique, idiosyncratic shocks to huge firms dictate GDP dynamics everywhere. The granularity hypothesis is absolutely a globally recognized, empirically tested phenomenon.
And if we zoom out from firms to entire countries, get this, international trade volumes are also governed by a power law, so we can actually find a granular size for global inflation, and that number is just 8. Literally, just 8 massive countries, the US, China, Germany, the UK, Japan, France, Italy, and the Netherlands, generate a share of inflation spillovers that vastly exceeds their actual share of global trade. These 8 massive grains basically dictate world inflation, which means central banks everywhere else are forced to watch them like hawks.
It applies to geography too. Because city sizes adhere to a power law known as Zipf's law, we can calculate the granular size of cities. In the United States, that number is 3. Just 3 major metropolitan areas have a massive, disproportionate influence driving the entire national business cycle. If you ignore the granular power of those specific cities, you are completely missing how the national economy actually functions.
Which brings us to Section 5, Beyond Economics, Nature, and Science. This is where we take an absolute mind-blowing leap.
Because power laws are everywhere in our world, granularity is everywhere too. Take avian ecology, the study of birds. The abundance distribution of birds based on rank follows a power law. And when researchers applied the exact same economic concept of granular size to ecosystems, just replacing corporations with bird species, they found the number 13. Just 13 specific bird species act exactly like megacorporations in nature, disproportionately shaping and impacting their entire ecosystem. Mind-blowing, right?
And it goes even deeper, right down to the atomic level. In chemistry, there's a power law that connects atomic numbers to atomic weights. The source material suggests that by calculating the granular size of this power law, scientists could actually accelerate the search for brand new, undiscovered elements in the periodic table. Think about that versatility for a second. We are taking a concept used to explain GDP fluctuations and using it to map the fundamental building blocks of the universe.
Which perfectly brings us to this concluding thought from the author Sergio da Silva. He states that the concept of granularity is potentially a Nobel-worthy breakthrough that heralds a new frontier for scientific inquiry across disciplines. It completely shatters the illusion of a smoothly functioning, perfectly averaged-out world, and instead reveals the massive hidden pillars that actually hold up our systems. So I want to leave you with this question. If the hidden rules of power laws and granularity are dictating everything from international trade to the birds in the sky and the atoms in the universe, what other invisible forces are shaping your world right now without you even realizing it? Thank you so much for joining me on this explainer. Keep questioning the structure of things, and I will see you next time.